Okay, so right now what we're doing is we're balancing classifying chemical equations because in terms of our learning objectives, we want to understand how atoms behave during chemical reactions and where they end up. And so that chemical or that atomic accounting starts with balancing chemical equations. And we carry through that later on with stoichiometry, okay, which is very heavily tested on the cast. And then we also want to be able to classify chemical reactions because we have to know as chemists at a broad level what types of processes are going on when chemicals react. And so I want to hear right now from, let's start with Estrella, okay? So Estrella, go ahead and get us started here. What can you tell us about the type of reaction or about which elements might currently be unbalanced?
Um, the classification is addition.
Okay, so Estrella says that this is an addition reaction. Okay. And why did you say that this was an addition reaction, Estrella?
Well, because you're adding C to oxygen, and
Okay.
then just equals into both of them.
So we have two chemicals, right? Making a third chemical. Okay. A plus B producing AB. This is absolutely an addition reaction. Okay. Very, very good. Who can tell us besides Estrella? Estrella, you might have this too, but I want to hear from someone new. Um, who can tell us another reaction type that this might be? Okay. And I'll give you a hint. I'm circling O2, right? What's another type of reaction that this might be? Who can help us out here?
C.
What now?
Combustion.
Combustion. Okay. And who was that? Leslie. Leslie, thank you. Okay. Very good, Leslie. So yeah, this could also be a combustion reaction, right? So it could also be a combustion because we're combining carbon with oxygen gas. So it could be an addition. It could be a combustion. Okay, addition or combustion. So I shouldn't do a slash because it could really be either or combustion. And it really, actually, it could be both because if it is an addition reaction, sorry, if it is a combustion reaction, it's also an addition reaction. So it really could be both. Okay. Um, all right. So now let's start the balancing process. So who can, let's see, I want to make sure I get around the class today. So I want to hear from Luis. Luis, I want you to take a look here at the left and the right sides of this reaction. Okay. How many carbons do we have on the left?
One.
Good. And how many carbons on the right?
One.
Good. So the carbons are balanced. Well, what about the oxygens? Are the oxygens balanced, Luis?
Uh, yes.
They are. We have the same number of oxygens on both sides of the reaction arrow. Is that true?
Oh no, just one.
Right. We've got two oxygens over here. We've got how many oxygens on this side, Luis?
One.
Good. So that's off. So what do we need to do in that case, Luis, to balance the oxygens? How can we balance the oxygens there?
Add.
Okay, how do we do that, or how do we represent that in the chemical equation?
Mm,
What do we do? So how many oxygens do we have on the left side?
Two.
And how many on the right side?
One.
Okay, so we got to put a 2 somewhere, right?
Yeah.
And we can't put it on the bottom here because that would change the chemical. So you can't do that, okay? You just can't put your 2's as subscripts. That's not okay. So where's the only place we can put a 2 on the right side, Luis?
On the left side.
Good. In front of the CO. Okay, now how many oxygens on the right side?
Two.
Exactly. We got 2 oxygens. We've also, however, got 2 carbons, okay? So Ruben, how do we balance the number of carbons on both sides then?
Yeah, to balance, you have to put a 2 in on the left side of the
Okay, now let's make our little table, right? Left side, right side, okay? And then with our little atoms, right? We got carbon and oxygen. Okay, Ruben, how many carbons on the left?
There's 2.
And how many carbons on the right?
2.
How many oxygens on the left?
2.
How many oxygens on the right?
2.
Okay. So scholars, my scholars, is this equation balanced? Is this a balanced chemical equation, guys? Need to hear from somebody, right? Is this balanced?
Yes.
Yes. Okay. Quite balanced. Our table shows the same number of each type of atom on each side of the reaction arrow. So that's a balanced chemical equation. Okay. So I want to erase this screen soon. Okay. So if you need to copy down your notes, take a screenshot or something or finish copying. I'm just going to open the floor really quickly for questions. Who's got a question about this?
What does
Okay.
it say, like, at the very bottom?
Renee, what now? It just says
Oh,
O2 and
2,
2.
Sorry.
Yeah, no worries. Yeah, you got to kind of like move your Zoom dock out of the way or whatever it is. Okay. Any other questions?
Question, Leslie.
Yeah, Leslie, what's up?
Why do you put a 2 in front of the CO on the right side?
Because, okay, good question, right? Because otherwise we wouldn't have balanced oxygens, right? We've got to have 2 oxygens on the right to match the 2 oxygens on the left.
Can't you just do CO2?
No, because that would change the chemical. CO2 is a different chemical from CO. They are 2 different chemicals. They are 2 different molecules. Okay? Can't happen. Very good question. Okay? So CO2 goes in and out of our lungs all the time, right? Carbon monoxide does not, okay? So CO is poisonous, whereas CO2 is perfectly inert, right? It doesn't cause any problems for us. We can breathe it in, we do breathe it out, okay? All right, other questions? Okay, then I'm gonna erase the board in 3, 2, 1. Okay, and I'm actually gonna erase it piecemeal because I wanna leave the top segment up. So, okay, new reaction type for now. All right, so here we go. So we're gonna go with a different reaction, and that is this one here. So we're gonna start with manganese, okay? Manganese reacts with hydroiodic acid to yield hydrogen gas plus manganese. This is called manganese 3 iodide, and I gotta rewrite that. Gotta leave a little more room for myself. And then almost get out of there. There we go. MnI3. Okay, 3 iodines there. All right, I gotta really kind of focus on that little 3. 3. Okay, that looks like, does that look like a 3? Doggone it, I like the toughest part of this transition
Is that
there we go. MnI3. Yeah, I3. Okay, manganese 3 iodide is what that's called. Okay, so I want you to take 4 minutes, okay? Try to classify this reaction, so go back in your notes and look. And I also want you to try to balance this chemical equation, okay? This is a really fun reaction here. So what type is it? And then how do we balance it, okay? And I'm gonna pause the recording. Okay, so Samuel, what can you tell us about either what type of reaction this is or what you see so far that's not balanced in the chemical equation? What do you see?
Is it single displacement?
Single displacement, okay. And why would you think single displacement?
I don't really know.
You don't know why?
No.
What is your formula for single displacement? What does it say in your notes?
AB plus CB plus A.
A plus what now? So for single displacement?
Yeah, AB plus CB plus
Okay. No, that's not correct. AB plus what?
plus CB, C.
No. Plus C. AB plus C yields what?
Well, it says AB plus CB plus A. That's what I said.
No, your notes are incorrect. Who can provide the correct formula for single displacement?
AB plus C equals A plus CB.
Correct. Okay. And so Samuel, take a look, right? So does this look like single displacement, right? So does the hydrogen get kicked out, right, by something else? Is something kicking out the hydrogen?
Yes.
Yeah, what's kicking out the hydrogen? What's taking hydrogen's place bonding to iodine?
Mn.
Good, that's manganese, okay? So manganese comes in and gives hydrogen the boot, okay? So hydrogen gets bounced and manganese comes in, okay? What's really cool, what's really happening in that situation is that manganese is actually giving electrons to hydrogen. And that's why this happens. But you can look at it from this other perspective too, of manganese kicking out the hydrogen. That's also just fine. So, okay, yeah, this is absolutely a single displacement reaction, okay? And so I'm gonna erase all this formulaic business and I'm gonna erase these arrows. Then I'm gonna write something, okay? So I'm gonna say manganese displaces hydrogen, okay? That's what happens there. So manganese displaces hydrogen. Whew, okay, so that's great. All right, so what's the deal here? So who can tell us what's missing on one side or the other here? Who can help us get started with that? Anybody willing? Okay, Terrell says yes. So guys, you just kind of have to share out or use your voices because it takes, I can't necessarily see everybody all at once, okay? So just go ahead and use your voices and share out that way. So, okay, so Terrell says he's ready. Okay, so Terrell, go for it. So what's something that you can, let's get us started, please, Terrell, on the balancing here. Mhm. Get us started. Never mind. Okay, so Terrell, are the hydrogens balanced? How many hydrogens on the left side? Huh?
One hydrogen.
How many hydrogens on the left side do we see?
How many hydrogens?
Yeah, how many H atoms? How many H's on the left side?
One.
One. How many hydrogen atoms on the right side?
Two.
Are those hydrogens balanced?
No.
No. Okay. So what's a quick way that we could try to balance those, right? If we wanted to balance them, what's one easy thing we could do?
Add another 8.
Sure. So we could put a 2 in front of HI, right? Then you'd have 2 hydrogens. You'd also have how many iodines?
2 iodine.
Right. But then how many iodines do we have on the right side?
3.
Okay. So then, Lillian, what's the least common factor between 2 and 3?
6.
Good. So what do we need to do on the right side to get to 6 iodines?
Multiply by 2.
Okay. So we got to put a 2 in front of manganese 3 iodide. Okay. So we put a 2 there, right? And then how do we make sure that we have 6 iodines on the left side if we've got 6 of them on the right? So look, 2 times 3, that gives us 6, right? So then how do we make sure that we have 6 iodines on the left side?
You put 3.
A 3 here?
Yeah.
Can't do that, right? Because then I'd only have 3 of them. Okay? 3 of them.
Wouldn't you keep the 2 there and then put a subscript?
I can't put a subscript, okay? If I put a subscript like that, I'm in real trouble, right? So I've changed the chemical, so I can't do that. All I can do is add coefficients, okay? So what number do I need to put out in front to have 6 iodines on the left?
6.
6. Okay, I got to put a 6 there. All right, there we go. So now I've got 6 iodines on both sides. Okay, so I want to hear from Zara. Zara, tell me how many hydrogens I have on the left side now.
6.
Good. And then what do I need to do to make sure that I've also got 6 on the right side? What number do I put in front of the H2?
4.
Okay, so if I put a 4 there, I have 4 times 2. Does that give me 6?
Oh, 3.
Good. I put a 3 in front of the H2. Okay, now I've got 6 hydrogens on both sides. That's perfect, right? So the only thing left to think about is manganese. How many manganese do I have on the right side, Zara?
2.
And then what do I need to do on the left side?
Add 2.
Okay, I put a 2 right there. Okay, 2 manganese on the left, 2 manganese on the right. Okay. Whew. All right, so let's see if this bad boy is balanced, okay? So I want some assistance from my buddy Angel Romero. Okay, so Angel Romero, let's make this table together, okay? We're going to shop class. We're busting out the lumber and making a table. So left side, right side, that was a terrible joke. And then we got all of our different chemicals. So we've got manganese, we've got hydrogen, and we've got iodine. And sorry, not our different chemicals, but our different atoms. Okay, so on the left side, how many manganese? Angel?
2.
Good, 2. And on the right side, how many manganese?
2.
2. Okay. On the left side, how many hydrogens?
6.
On the right side, how many hydrogens?
6.
Yep. Okay. So 6 times 1 is 6. 3 times 2 is 6. Okay. Great. And then iodines on the left side?
6.
And on the right side?
3.
So 3 times what?
6.
Okay, 3 times 2 gives us 6. All right, so we got 6 iodines on both sides. Okay. Woof. All right. So is this equation balanced, scholars?
Yes, sir.
Yes. Okay, very good. All right. So now I'm going to open the floor. I'm going to pause the recording, and I'm going to open the floor to questions. Well, I'll open the floor to questions while leaving the recording on, but I'm going to open the floor to questions on this chemical equation. So who's got a question about this chemical equation? Okay, no questions? All right, so I'm gonna go ahead and erase the reaction, and I'll pause the recording, or no, I'll pause the recording in a second. So if you do have an equation or a question that you'd like to share just with Ms. Sandoval or me, please chat, okay? Use the chat, ask Ms. Sandoval, ask me what your questions are, okay? Because I want everybody to do well on our little mini quiz coming up today. Okay, again, it's just completion points, but I want us to all do well. That gives us a sense of pride, right? That we understand what we're doing. It makes us happy. So, all right, so we've got one more reaction that I definitely want us to look at before we start taking our mini quiz and before we start handing in our notes for the day, okay? So here's our last equation that we'll look at for the day. So as a group, so we've got aluminum, right? Plus oxygen gas, or sorry, not oxygen gas, like that oxygen gas yields aluminum oxide, okay? So this is an important reaction, and it happens when things rust. Okay, no, sorry, it doesn't happen when things rust. That's when iron, sorry, when iron does that with oxygen, things rust. No, this is just aluminum's oxidation. So aluminum metal can oxidize, right? And so it can form aluminum oxide. So I want you to go ahead and balance this chemical equation, okay? Balance, and also figure out what type of chemical reaction it is, okay? Find the type and balance the equation. You've got 4 minutes. I'll pause the recording now. So what, Edson, what were you thinking? What's going on?
Is it double displacement?
Double displacement, right? Well, remember, double displacement has 2 products, right? Do we see 2 products here? How many chemicals are over here, Edson, on the product side?
1.
1 chemical, right? So it can't be a double displacement. How many chemicals do you have on the left side, on the reactant side?
2.
So 2 turning into 1. What does that sound like? Look at your notes, Edson. two chemicals joining into one chemical. What do you think that could be?
Can I just say it?
No, let Edson get this. He's got this. Edson, look at your notes, dude.
Is addition?
Aha. Okay, so one option is addition, right? Okay, so you got A plus B turning into AB. Very good. Now, Victor, you wanted to chime in, and that's fine. So, Victor, what happens when you combine with oxygen? What type of reaction can that be?
Combustion.
Aha. Addition or combustion, right? Right? This could totally be a combustion reaction. It could be both, actually. Okay? So those are the types of reactions that are possible here. Okay, so Victor, I'll stay with you. What's currently unbalanced? Okay, are the aluminums balanced?
I low-key need help with this. I'm
What
still
now?
kinda-
Okay, but let's just help me out here. We got 2 on the right. How many do we have on the left?
One.
One.
Okay, so are they balanced?
No.
Okay, that we know, right? We know they're not balanced, okay? So what about the oxygens? Are the oxygens balanced on either side? We got 2 on the left. How many oxygens on the right?
3.
Okay, so are they balanced?
No.
No. Okay. So here's what we got to do. So who feels like sharing on this one? Who thinks that he or
I
she
can.
has this one?
think I
Who's
got
got
it.
this?
I think I got it this time.
Who's that? Who thinks he has it?
Real.
Terrell. Okay. Terrell, get us started. What do you think we need to do here?
I think you need to change AL from the first side to a 2, and then how AL2 you would have to find the common what's it called? How you did to 2 and 3.
Okay. So we got to have 2 of these over here, right?
Yeah.
And that gives us how many oxygens, Lillian?
6.
6. So then what's the number, Terrell, that you have to put in front of the O2?
6.
No, because you got 2 here. So 2 times 3 equals 6, right? So we got 6 oxygen atoms. So what number do we have to multiply by this 2 to get to 6?
3.
3. Okay. Ruben, is that what you had?
Yeah.
Good. Okay. Now there's just one last thing, and Lillian, I want you to knock this out. Good job, Terrell. Okay. Lillian, what's the deal with aluminum? What do we have
You
to
need to
put?
put a 4 in front of it.
Aha! On the left side, we have to have a 4. Okay. So I'm not going to draw a table this time because we have some things to get around to, but we'll just take a look, right? 4 aluminums, and then we got 2 times 2 gives 4 aluminums. Then you got 3 times 2, that's 6 oxygens, right? So you've also got 2 times 3, that's 6 oxygens, okay? So this equation is balanced, all right? That's what this guy should look like. So I want to erase it pretty quickly, but go ahead and get it into your notes, okay? Take a screenshot if you need to. I need to start erasing the board so we can get into our last piece of business for the class, okay? So I'm going to erase this board in 3, 2, 1. Okay. Board is erased. All right. So last 2 things for today, okay? 1, okay? Complete, and I'll send this out through the chat in a second. I'll also post it on Google. It's also already posted on Google Classroom, but complete, okay? Google, Google form. Okay, and it's going to be in the Zoom chat. It's also currently on Google Classroom too, because I had to put it there for anybody who might miss class. And then after you're done with that, you're going to turn in your notes. Turn in notes. Okay? And that happens on Google Classroom.
Oh, Mr.
This is Dr. J. That's me. What's the scoop, Terrell?
So when you always use 2 to multiply with the numbers added to the like, you know how you did AL2O3?
Yes.
Would you always use 2 to multiply to those numbers?
That tends to work when you've got a 2 on one side and a 3 on the other side. I can't give you an absolute rule for that, but that tends to get the job done, okay, when you're dealing with like a 2 somewhere and then a 3 somewhere else, okay? You'll get a sense for that as you do more of these problems, okay? So copy the link. Okay, and it looks like some of us are already doing the Google form. So you guys already found that. That's really good.
Dr.
Okay.
J.
And then I'm gonna, give me just a second. I'm just gonna put in the chat. Here's the link. Okay, so Google form.
Dr. J.
Hold on. Give me, I just told you, give me a second. Okay, yeah, who's this?
Erica.
Erica,
Is
what's up?
is the check-in worth a grade?
Okay, you have to do it, right? It's worth a completion grade. So you can miss them and still get credit, okay? But you have to do it. But I want you to try, okay? Try your best. So the link is in the chat room. It's also on Google Classroom, okay? So go ahead and complete the Google form. It looks like a number of us are doing that now. Do the Google form first and then get your notes in, okay? So Google form and then notes. So I'm looking at this and a lot of us are doing well, right? So now we've got 4 new responses, okay? And the average score is clearly 2 out of 2. So most of us are getting them all right, okay? So who's answered from our class so far? Okay, so Samuel, good job, Samuel. Samuel got them all right, okay? Very good, Samuel. Okay, so we're answering. Okay, so very good, Samuel. So guys, the link is in the chat. Okay, click on the link in the chat and do the Google form, and then immediately submit your notes on Google Classroom, okay? And I'll get over to, okay, Samuel got them all right. And Ariadna got them all right. Nice job, Ariadna. Okay, nice job. All right, and Terrell got them all right. Very good, Terrell, right? So we are crushing this, guys. This is our day. This is our day. And let me see if I'm still recording. Okay, I'm still recording. Guys, I'm gonna stop the recording. We're doing great.